Saxon Algebra 2, Lesson 43. Welcome, my students, to a pivotal day in your life. You didn't know this day was coming. You had no hint of the dreams that are about to come true. Today is the first day that you're going to study trigonometry, and it is going to blow your mind. Trigonometry is the study of triangles. In particular, we're going to spend a ton of time talking about our dearly beloved right triangles. And I'm going to explain to you in a nutshell how trigonometry operates, and then we'll get into the nuts and bolts. Here we have two triangles. They look kind of alike, except one's a lot smaller and one's a lot bigger, but they look kind of proportional to each other, don't they? I tried to draw them proportional, so play along. Say, yeah, those look really proportional, especially like this little squished part here. Never mind. They are both right triangles. That is extremely important for the next year plus. Whenever we talk about trigonometry, it's not only going to be a triangle, but it's going to be a right triangle. Now, let's imagine we've got these two triangles, and these are both 30-degree angles here. Okay, whoops, I forgot to write the 30. All right, that's pivotal because even though the lengths of these sides are going to be unique, the ratios that we make, so for example, if I create a ratio using the smaller triangle of, let's say, this side over this side, it would be 2 over 4, right? And this is the ratio of, imagine that we're standing here. Okay? So when I'm here at this 30-degree angle, the ratio of what we would consider to be the opposite side over the hypotenuse, if you want to think of it that way, this is opposite from where we're standing. This is the hypotenuse because it's the opposite the right angle. That would be 2 to 4, right? If this is 2 and this is 4, which equals 1/2. This is on the the smaller triangle. But if we look at this big triangle, again, we have a 30-degree angle. And if we look at the opposite over the hypotenuse, that will be equal to 120 over 240, and that's also equal to 1/2. That's what trigonometry is all about, is that if we have right triangles and we're looking at the same size angle in another corner, even if the lengths of the sides are wildly different, the ratio of the pairs of sides will be the same. That's the magic on which trigonometry is based. Okay? So what we're doing is we're looking at ratios of the sides, knowing that for any angle, that will be a very specific ratio. And here's the cool thing. Our calculators are loaded up with all of this data so that we can use our calculators to solve this. We don't have to do calculations in our head. We've got our calculators to help us out. So what we do is we create 3 different ratios that we can make using these 3 different sides, and we give them names. We've already looked at the first one. That's the pair that we call the opposite and the hypotenuse. And of course, whenever we talk about these things, it has to be relative to a certain angle, right? And so let's just call that angle A. Okay, we'll have different names for it along the way. But right now we're saying that at angle A, for any given size, if you take the opposite over the hypotenuse, that will give us a specific ratio. We found that if it's a 30-degree angle, it's equal to 1/2, but if this is a different size angle, the ratio will change. Like I said, they're all programmed in your calculator, so you don't have to worry about it. And this particular combination, well, before I do that, let me say another pair that we combine are what we call the adjacent, or what we call the adjacent side over the hypotenuse. Okay, so opposite over hypotenuse, adjacent is the closer one over the hypotenuse, and then the third combination is if we take the opposite and put it over the adjacent. Okay? These particular pairs we use over and over and over and over again. So instead of calling it the opposite over the hypotenuse or the adjacent over the hypotenuse or the opposite over the adjacent, which is way too many syllables for us to have to spit out every time we want to talk about these, mathematicians, specifically trigonometricians, have given these three ratios cute little names. This one is called sine. This one is called cosine, and this one is called tangent. Okay, later, I think it's in advanced algebra, so another year out from where you are now, we're going to get into a lesson that explains how these names came to be, which is really cool. But for now, just know that these words simply refer to pairs of the sides. Okay, now we're going to abbreviate all of this because this is a lot to remember. We have to memorize all of this. But what we're going to do is we're going to abbreviate the three functions. These are called the trig functions, fancy name for ratios, fancy name for fractions, and tangent. Okay, so we abbreviate, but we still say sine, cosine, and tangent. We don't say sin, cos, and tan. No. We say sine, cosine, and tangent. It's just like any other abbreviation. You say the full word. And then we abbreviate these so that we don't have to spit out all those syllables every time. This is highly memorizable. And we're going to commit this to memory. Don't worry, you won't even have to try. We're going to use these so many times that they'll jump right into your head. But I'm going to teach you a little story. I'm going to tell you a little story that will help you put this all into your memory. Do you know Oscar the Grouch? Yes, you do. He's on Sesame Street. He's the green guy. He lives in a trash can, and as his name implies, he has a bad temper. He's a grouchy dude. He lives in the alley, right? Because that's where, at least back in the day, trash cans always accumulated. And he's not your friend. All right. Also in this story is Arthur the Aardvark. You probably know him. Could be from the books. We read the books a lot. He also has a TV program, animated. But Arthur's an innocent little aardvark. He wears normal clothes, human clothes, and glasses. He's got a sister named DW and a friend named Francine. And he's got parents. And he's just kind of a normal little dude. He goes to school. He has a, blah, blah, blah. He has a normal little human-like life. So he's highly anthropomorphized. But he's sweet and he's innocent. Now, our story begins when our sweet, innocent friend Arthur accidentally walked down the alleyway where Oscar the Grouch lives. And friends, that was a bad plan, because what happened was Oscar got super territorial and very upset, and he jumped Arthur. Now, how he jumped him, because, spoilers, Oscar's a puppet, and he can't get out of his trash can. I'm sorry if I destroyed your childhood there. But Oscar is a puppet. And to make matters even more confusing, Arthur's an animation. But just work with me on this. So what happens is Oscar sees Arthur the Aardvark toddling down his alley. Arthur's got his hands in his back pockets, and he's just whistling a little song. And Oscar sees him, and he boing, 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 jumps over to him in his trash can, I suppose. Like a little Jack-in-the-Box jumps. and he tackles Oscar, knocks him to the ground, and begins to put his hands around his neck, and he's just choking the life out of Arthur. That's the image that I want you to freeze into your brain. I'm sorry if that scars you. That is quite scarring. But you need to remember this. You need to have in your mind this visual picture of Oscar, the green fuzzy grouch, in his trash can, shaking the living daylights out of this poor, innocent schoolboy who's an aardvark, although it really never looks like it. Little Arthur with his glasses knocked crooked. And that's where our device is going to come in, because what you're going to remember is that Oscar, copy all this with me, Oscar had a hold over Arthur. This sentence, which the first letters of which define all these pairs, that's the picture I need you to capture in your mind of Oscar the Grouch choking poor Arthur, because in that tortured image that may make you wake up screaming in the middle of the night, palms sweaty, heart beating fast, you will remember OHAHOA. Okay? That's our game. There are other ways to memorize this, and I might mention them later to you. But I'll tell you what, this is what's burned in my brain. It's extremely graphic, which is the whole point, right? Our brains remember stories that have strong emotional content, and our brains remember stories with motion in them. So I stressed both of those things to you, right? It's a little violent, but that's okay. It'll help you remember it. So Oscar had a hold over Arthur. You get it. I am going to use these all the time. If I'm referencing sine, I'll say a hold. Right? It'll sound really weird and disconnected, but you'll remember, oh yeah, this story, that's how it works. And you will be fine with that. All right, so what we do when we are working with these problems, I'm gonna flip. What we do, I'm gonna copy my list down again. Now, I mentioned that there's an angle associated with it. So when we write these out formally, we will say sine, cosine, or tangent of a specific size angle. This will be a degree measurement. And this, although I've written it as a fraction, when we simplify that in our calculators, this will become a decimal. Okay? And we can say these things are equal. All right, when we are using one set of buttons on our calculators, and I'm going to show you this in just a minute, sine, cosine, and tangent, these are the buttons. This usually means we know the degree of the angle, we know this information, and we want the decimal number. Okay, the decimal comes from the fraction of these pairs, but normally we just want the decimal of top divided by bottom, right? That's one set of functions. There's also a set of buttons, and I'm going to show you them in just a minute, that look like this. And these are what we call, I'll talk about this later, but I'm going to just tell you the word right now. These are what we call the trig functions. And these are what we call the trig inverse functions. The -1 isn't literally a negative reciprocal. It's just the way our calculators code the fact that this is the different button. And in these, we know the decimal number, and we want the degree of the size of the angle, okay? So make sure you copy all of this down. It is super important. And here's what I'm gonna do. My phone which is my calculator, is busy recording this lesson. So I am going to stop this video. I'm gonna go borrow one of my daughter's phones so I can lay the calculator out in front of us and show you how to operate it. And then we will finish this lesson, okay? So take the time between the ending of this one and when you start the next one to make sure you get all this information captured. And I'll see you in a minute. Thank you. Peace.